Hierarchical clustering. We discussed the clusterings from a probabilistic point of view as fitting a mixture model to the data, or in terms of finding code words minimizing reconstruction error. There are also methods for clustering that only use similarities of instances without any other requirement on the data. The aim is to find groups such that instances in a group are more similar to each other than instances in different groups. This is the approach taken up by hierarchical clustering. This needs the use of a similarity or equivalently a distance measure defined between instances. Generally, Euclidean distance is used, where one has to make sure that all attributes have the same scale. This is a special case of the Minkowski distance with p equals to 2. That is, dm of x to the r, x to the s, those 2 points, is equals to the summations of xj to the r minus xj to the s to the p, and the summing for all index j is starting from the first dimension to the dth dimension. And after we do the summation, we take to the exponent of 1 over p. City block distance is easier to calculate. That is dCB, the synonym of a city block, of 2 points x to the r and x to the s is equals to the summations of absolute distance between xj to the r minus sj to the s, summing for all indexes j starting from 1 to d. An agglomerative clustering algorithm starts with n groups, each initially containing one training instances, merging similar groups to form larger groups until there is a single one. A divisive clustering algorithm goes in the other direction, starting with a single group and dividing larger groups into smaller groups until each group contains a single instance. At each iteration of an agglomerative algorithm, we choose the two closest groups to merge. In a single link clustering, the distance is defined as the smallest distance between all possible pair of elements of the two groups. That is, d of gi gj is equals to the minima of d of x to the r x to the s, where the minimization is taken among x to the r in gi and x to the s in gj. Consider a weighted, completely connected graph with nodes corresponding to instances and ages between nodes, with weights equal to the distances between the instances. Then the single link method corresponds to constructing the minima spanning tree of this graph. In a complete link clustering, the distance between two groups is taken as the largest distance between all possible pairs. That is, d of gi gj is equals to the maximum of the distance of x to the r, x to the s, where the maximum is taken among all possible x to the r in gi and x to the s in gj. These are the two most frequently used measures to choose the two closest groups to merge. Other possibilities are the average length method that uses the average of distances between all pairs and the centroid distance that measures the distance between the centroids means of the two groups. Once an agglomerative method is run, the result is generally drawn as a hierarchical structure known as the dendrogram. This is a tree where leaves correspond to instances, which are grouped in the order in which they are merged. An example is given in figure 7.5. The tree can be then intersected at any level to get the wanted number of groups. Single link and complete link methods calculate the distance between groups differently that affect the clusters and the dendrogram. In the single link method, two instances are grouped together at level h if the distance between them is less than h, or if there is an intermediate sequence of instances between them such that the distance between consecutive instances is less than h. On the other hand, in the complete link method, All instances in a group have a distance less than h between them. Single-link clusters may be elongated due to this chaining effect. In Figure 7.5, what if there were an instance halfway between E and C? Complete link clusters tend to be more compact.